Trước khi bắt đầu, nếu bạn đang tìm kiếm sách để học IELTS hiệu quả, thì đây là những cuốn sách chúng mình khuyên dùng. Nó có thể giúp bạn đạt điểm IELTS từ 7.0 tới 8.0. Bạn hãy xem ở phần giỏ hàng trong kênh nhé.
Part 1. You will hear a conversation between a receptionist at a dermatology clinic and a patient booking a skin patch test.
Good morning, Linden Road Dermatology. Ryan speaking. How can I help?
Hi, I would like to book a skin patch test, please. I keep reacting to skincare products.
Certainly. Patch testing checks for contact allergies. I will take a few details first. What is your full name?
Amelia Brown. That's Brown for the surname.
Thank you. Do you have a reference code? Some patients get one from their GP.
Yes, it is PT618. PNT, then 618.
Great. Can I have a contact number?
Yes, it is 07812 445907.
Thanks. Now, the first appointment is for applying the patches. We have Wednesday at 9:30 or Friday at 2:15.
Wednesday at 9:30, please.
Fine. We're on Cranford Quay Road above the chemists. That is Cranford. Cranford.
Okay.
Just so you know, the patch test involves 3 short visits. On day 1, we apply small patches to your back. You keep them on for 2 days, and you return after 48 hours so we can remove them. Then you come back again on day 4 for the final reading.
Right.
Now some preparation. For the week before the test, please avoid trying any new products. Keep using anything you already tolerate well, but do not start anything new.
Okay.
Also, on the morning of the appointment, do not put moisturizer on your back. It can stop the patches sticking properly.
Got it.
While the patches are on, keep the area dry, so no swimming. Also, avoid the gym because heavy sweating can loosen the tape. A short walk is fine.
Understood.
The total fee is £55. That covers all 3 visits. If we need extra panels later, we will discuss it then.
That is fine.
Before I confirm the booking, what's the best way to contact you?
Email, please.
No problem. I'll email the confirmation now. See you on Wednesday.
Part 2. You will hear an event coordinator giving information about seating arrangements and facilities at an outdoor cinema.
Good evening, everyone, and welcome to the Open Air Cinema. My name is Joel, and I am the event coordinator. Before the film begins, I will explain the seating areas and where the main facilities are so you can get settled quickly and avoid moving around once the trailers start. First, timings. The gates open at 6 p.m., but we recommend arriving at 6:30 p.m. That gives you time to come in, find the right section, and buy refreshments before the trailers begin at 7:15 p.m. If you arrive later, please use the central path and walk quietly to your place so you do not block anyone's view. Now, a quick note about chairs. You may bring your own chair, but it must be a low chair. High-backed camping chairs block the view for people behind you, so please do not use them in the main seating blocks. If you have brought a tall chair, use the picnic blanket area instead, or sit right at the edge of your section. Next, the weather. This is an outdoor event, so light rain can happen. We do not provide ponchos. If it starts to rain, please stay in your seating area and use your own waterproof layer. If conditions become unsafe, we will make an announcement and our staff will guide you. Now to the layout. Please keep the central path clear at all times. It runs from the main gate straight towards the screen, and it is the main access route for staff, wheelchair users, and anyone who needs assistance. Let's start with seating. The family seating area is on the left side of the site, behind the VIP area, so families have a little more space. Wheelchair seating is also on the left, but it is closer to the central path with flat access towards the screen. Regular seating is on the right-hand side in the main block near the lake. Finally, facilities. Toilets are along the front walkway on the right-hand side near the main gate. The snack stall is on the opposite side along the front walkway on the left near the corner. The staff booth is at the top right of the site near the screen. If you need to speak to a member of staff during the event, that is where we will be. Before I finish, a couple of small reminders. Please keep phones on silent and avoid using bright screens once the film begins. If you need to leave during the show, wait for a quiet moment and use the central path. Rubbish bins are by the main gate, and children should stay with an adult, especially near the lake. Thanks for listening and enjoy the film.
Bạn đang nghe podcast miễn phí tại IELTS. Nếu bạn yêu quý kênh, hãy ủng hộ chúng mình ở phần mô tả nha.
Part 3. You will hear two students discussing a lecture on outliers and different ways to identify or handle them.
Hey, Sarah. How was the class on outliers?
It was clearer than I expected. I used to think outliers were just bad data, so I deleted them.
Same. But the lecturer kept repeating, do not remove anything before you check context and data quality.
Yes, first we should ask if it is a data error, like a typing mistake, or if it is a real rare event.
That point mattered. If you delete a real rare event, you might hide something important.
Exactly. Like a sudden big purchase could be fraud, or a machine reading could show a failure. Those rare points may be the most valuable.
So, we both think removing outliers should only happen after checking the reason, and deleting them can hide real but rare events that matter.
In the group talk, someone predicted companies will use one universal threshold for every dataset. They said just use 3 standard deviations for everything.
I doubt that. Different data behaves differently. One threshold for all datasets is too simple.
Another prediction was that unsupervised anomaly tools will replace rule-based checks entirely.
I'm doubtful about that too. Companies like rule-based checks because they're easy to audit and easy to put into dashboards.
Right. Models can help, but rules will not disappear.
Let us review the methods we studied. First, the z-score rule.
That's the classic one. If a value is far from the mean, it may be an outlier.
But the lecturer warned it breaks down when the data has heavy tails.
Yes, if the distribution naturally has many extreme values, z-scores can mark too many points as outliers, even when they're normal for that dataset. Next was the IQR rule, also called two-key fences.
I remember. It uses the middle 50% of data and sets limits based on the IQR.
The lecturer said it's often more reliable for skewed data than z-scores.
Yes, because it doesn't depend on the mean and standard deviation as much.
Then we discussed winsorizing.
That was interesting. Instead of deleting outliers, you cap them.
Like, if a value is above a certain limit, you set it to the limit, not remove it.
So, you reduce the impact of extremes without deleting records.
It's a compromise, especially when you still want the row to stay in the dataset. We also talked about robust regression, for example, using Huber loss.
The key idea was that it helps modeling because it resists outliers instead of chasing them.
Right. Ordinary least squares can be pulled strongly by a few extreme points, but robust methods reduce that influence.
Then there was isolation forest.
The lecturer said it can spot unusual cases well because it isolates strange points quickly.
But it can be hard to explain to managers.
Yes, if you tell a manager the model isolated this point, they may ask why, and the explanation is not simple. Finally, we discussed manual rule-based flags or business rules.
These are everywhere in real jobs. Like, if a transaction is over $10,000, flag it. Or, if a login happens from a new country, flag it.
But the lecturer warned that it depends heavily on domain knowledge and clear definitions of normal.
Yes, and two teams might disagree on what's normal.
So, in practice, we need balance, rules for transparency and models for complex patterns.
And we must document what we do, because outlier decisions can change results.
I agree. Outliers are not just numbers. They can be errors or they can be important signals.
Part 4. You will hear a lecture about a phenomenon in space known as nomad planets.
Good morning, everyone. Today I'm going to delve into a fascinating cosmic phenomenon. We are discussing nomad planets, sometimes referred to as rogue planets. For decades, conventional wisdom dictated that celestial bodies orbiting a central star were the absolute standard arrangement. In fact, if you asked researchers 30 years ago, they'd have confidently stated that worlds drifting alone in the dark void of space were exceptionally rare. We now recognize our own galaxy might be teeming with billions of them. But how do these massive bodies end up isolated? When planetary systems form from swirling disks of gas, it's a highly chaotic environment. Gravitational interactions between protoplanets are extremely volatile. Older computer models couldn't quite map out this complexity, meaning they completely missed the likelihood of early ejection. We understand today that young planets are literally thrown out of their native systems during these violent formative years, left to wander the cosmos entirely alone. So how exactly do we spot something that doesn't orbit a star? They don't emit visible radiation, so we can't just point a standard telescope at the sky and expect to see them. Instead, we rely on a technique called gravitational microlensing. This occurs when a nomad planet passes directly in front of a distant background star. The planet's gravity bends and magnifies the star's illumination. By carefully recording these temporary variations in light, astronomers can confidently deduce the presence of the invisible planet passing by. A breakthrough in this methodology happened thanks to a dedicated team at the Wellinger Institute. They were reviewing archival data from deep space scanning arrays when they spotted an anomaly. It wasn't a standard planetary transit that they were used to seeing. What they successfully identified was a rapid, sharp distortion in the visual field. This unique warping effect proved to be the gravitational footprint of a massive wandering object. There is another observation strategy we use which specifically focuses on very young nomad planets. Just after they form, these objects are still incredibly hot from the massive friction of their birth. This retained heat means they radiate energy in specific wavelengths. Space observatories can detect these giants by capturing this faint infrared signature before the planet cools down completely over millions of years. Now, let's move on to the most intriguing question. Could these dark, wandering worlds harbor biological life? Your immediate assumption might be no. Without a reliable host star nearby, they simply don't receive any vital warmth. The surface temperatures would quickly plummet to near absolute zero, making them seemingly frozen wastelands completely devoid of biological potential. But the chemical precursors necessary for life might find a way to survive. Some planetary geologists propose that these isolated worlds might have retained massive, deep oceans. While the surface would undoubtedly freeze solid in the vacuum of space, this thick outer shell of ice could theoretically serve as an excellent planetary insulator. It would essentially trap whatever thermal energy remains safely deep inside. And where would this critical internal heat come from? Deep inside the rocky core of such a planet, unstable heavy elements gradually break down. The continuous radioactive decay of these materials releases a steady supply of geothermal energy. This exact process happens right here inside Earth and could easily heat the subterranean oceans of a nomad planet. Furthermore, a nomad planet might possess a very dense atmosphere. If the planet is massive enough to hold on to a thick layer of primordial hydrogen, the resulting atmospheric pressure would be absolutely colossal. Under such extreme physical forces, water can be kept in a fluid state even at much lower temperatures, creating a stable, habitable zone far below the dark clouds. Looking ahead, our picture of the cosmic neighborhood is about to get much clearer. Next-generation space observatories are being prepared for launch within the coming decade. These highly sensitive instruments won't just count the total number of nomad planets. Their primary objective will be to analyze the exact chemical composition of these dark worlds. By breaking down the complex spectroscopic data, we'll finally learn what these mysterious drifters are actually made of, revolutionizing our entire understanding of planetary physics.
Bạn đang nghe podcast miễn phí tại IELTS. Nếu bạn yêu quý kênh, hãy ủng hộ chúng mình ở phần mô tả nha.